Okay, hello everyone again to part 3, and this is the final part of this introduction to COCO and ChemSep. And last time we had simulated the very first column in this benzene, toluene, xylene distillation example. And if we take a look at the COCO flow sheet that we ended up with, this was our COCO flow sheet. Again, we had just solved the first column, and we're ready to put in the second column, but there's going to be a recycle stream just in front of the second column. So the first thing we're going to do is actually put in a mixer. So if we go to the Select Unit Operations icon and look at the Mixer and Splitter node, we can click on Mixer and select it, and then we can locate it right near the exit stream that comes from the bottom of that first distillation column. And one of the inlets to the mixer is going to be the bottom product, so we can left click on the bottom product. Notice it gives us a black dot on the arrowhead. We can grab that by left clicking on the black dot and then dragging it into the mixer, and it wants to confirm that this is inlet number 1, and indeed it is inlet number 1. Notice that the mixer is not very fussy. It does allow us to connect to it before we open it up because it's so simple. But we need the second inlet column to the mixer. That's going to be a recycle stream. And temporarily, we're going to make an approximate recycle stream, and then we'll be able to connect it to the outlet of that paraxylene separation unit later. So I'm going to left-click on the Insert Stream icon, left-click on that, and let go, and then left-click again at about this location in the flow sheet, let go of it, and then left-click again so it gets connected as the other inlet to the mixer. And I'm going to have to give some approximate composition for that stream. Right now, it's essentially a feed stream. Eventually, it's going to be a recycle stream, and either way, I've got to specify something. If it's a feed stream, obviously, I have to specify what it is. But even if it's a recycle stream, I've got to specify something that will be used as a starting gas. Right now, it's going to be essentially a feed stream. So I can right-click on it, and then I can left-click on the Edit View Streams. And again, I'm going to specify pressures 1 atmosphere, so 101,325 for the pressure. Temperature 298. And the composition of this, it's going to be our toluene orthoxylene recycle. So approximately, I'm going to say it doesn't have any benzene in it. And it's 0.5 mole fraction toluene. It's a recycle stream, so I really don't even know what it is at this point. But it's not going to have any metaxylene. It's going to have 0.5 mole fraction orthoxylene. And right now, I'm going to give it a flow rate of 0 because I don't want it to affect the answer. Later, I might change that when I use this information as a starting gas. But right now, it's a stream that has 0 flow rate, so it's not even going to affect the solution. It's kind of a temporary placeholder, so that's all okay. Notice it's turned black. Eventually, I'm going to take the tail end of this stream, and I'm going to drag it backwards and connect it to the outlet of the xylene unit because it's the recycle stream. And right now it's just a sort of a temporary second feed stream that has a 0 flow rate, so it does not affect the answer. I need something that comes out of the mixer, so I need the product stream, so I'm going to left-click on the select stream icon. Then I left-click again towards the pointy end of the mixer, let go of the mouse, and then move the mouse to a new location, left-click again, and I've got my product stream. And what I can do is, it might be interesting to open up the graphical user interface for this mixer. It's very simple. There's hardly anything to it. In fact, I'm not sure you can do anything. It just mixes what goes into it. I guess you can change the ports if you wanted to. The mixer is about as simple as you can get. There's not much to adjust to it. But it's black. It hasn't been solved, so we could solve it. So right-click and calculate this unit. Didn't take long to solve it because it's pretty trivial. So now it's actually solved. And possibly we want to resolve the whole system. I guess we could do that. Maybe for the sake of illustration, I'm going to resolve the whole system. And we'll probably see that one harmless error dialog box again, but let me resolve the whole system. So now it's solving that first column again. I'm pretty sure, no, it just solved the whole thing. So it's all green, and it's all been solved. Of course, the mixer is a totally trivial thing to solve, especially since we had 0 flow rate in one of the inlet streams. But just to check on the outlet stream, you can see if I hover the mouse over the outlet stream, you can see the composition in the outlet stream. It's just the same as the composition coming out of the first column, the benzene column. But now I'm going to solve the toluene column. So I need another distillation column. So I'm going to click on the Select Unit Operations button and open up the separations node and click on ChemSep and say Select. And then I've got to move the icon, say right here. Okay. And it probably is not going to let me connect that outlet stream. Let's see if it'll let me connect it. I don't think it will because it wants me to open up the graphical user interface. No, it didn't allow me to drag the head of the stream into the icon. So it is saying I've got to open up the graphical user interface and check that everything is okay. And again here, we're just going to leave everything the way it is. This bottom one, the thermal model, is kind of the most useful one. Cape open means I'm just going to use the thermodynamic model defined for the whole flow sheet. Sometimes it's useful to change that so I have a different thermodynamic model for the unit. For example, solvent extraction. I'm going to want to switch from the gamma phi thermodynamic model to a gamma gamma model. And so in that case, I would want to select the other option, ChemSep, but I'm going to stay with Cape open here. And this other stuff I can change later. So the only critical one that you really cannot change later is whether you're going to have a separate thermodynamic model for the unit or whether you're going to use the one for the whole flow sheet. So Cape open means just use the one for the whole flow sheet. Okay, so say OK. And it's going to take a couple seconds to open up the ChemSep user interface. And here's the ChemSep user interface. All the green check marks means actually everything is set, but it may not be set correctly. So we'll check everything. Components, again, are going to be benzene, toluene, and the xylenes. There's not much benzene present because most of it was removed, but there's at least a little bit, so that component is still there. The operation, it's a simple distillation column and a total condenser at the top, partial reboiler at the bottom. And you might remember we had an approximate number of stages, an approximate feed plate location, just so we can do a simulation. And again, I kind of forget that number, but it was maybe 68 plates, approximately. Actually, may have been more like 76 plates. So I'm going to say 76 plates total. And then click, and I'm going to allow it to use its best judgment to find the feed plate location. So approximately 76 plates in the column, feed at the stage number 38. And it's only an approximate design to get a simulation, and we're going to fine-tune the simulation using the Fensky-Underwood method. Notice that we don't have that FUG node yet in the results section because we have to do a successful simulation, because the software has to know how you calculate the equilibrium between vapor and liquid before it can show us the FUG Fensky-Underwood node. So we're not at that stage yet. So let's take a look at, okay, the properties we cannot change. It's going to be the default one. In fact, it doesn't even show us what the properties are, but that was that gamma phi, the predictive Soave-Redlich-Kwong equation for the vapor, and the UNIFAC method for the liquid activity coefficients. The feed's not connected, so it's not going to show us the feed. And specifications, okay, the column specification. So you might remember back on part 2 of this lecture, or this video series, this column we had 95% purity of toluene at the top and 85% recovery of toluene at the top. So top specification, we can say it's mole fraction of a component. It's not benzene. You have to remember to change that. Toluene, the mole fraction of toluene at the top, and it's definitely not 2. If I remember right, it was 0.95 mole fraction. Toluene at the top. Remember, it hit enter, so it's really entered. And we have 85% recovery of toluene at the top. And remember, it's one of the characteristics of ChemSep that you've got to specify one thing at the top and one thing at the bottom. So we've got to convert that recovery at the top to a recovery at the bottom. Very easy. We can do the material balance in our head. If we recover 85% of the toluene at the top, we'll be recovering 15% of the toluene at the bottom. So we have to select component recovery. Make sure you don't leave it as benzene because we want toluene, and it's actually 15% at the bottom. Whoops. 15%. Remember to hit enter to make sure it's entered. You just put a number there and don't do anything else. It hasn't really been entered. So that should be okay. That should be okay. Problem should be completely specified, except efficiencies. Again, the efficiencies are not 1, but 0.8 in this problem specification. So remember to change stage efficiencies to 0.8. And everything else was okay. Just check the pressure here. The pressure was at 1 atmosphere, constant pressure. I could change all that, but this problem specification corresponds to that. So I believe I'm all ready. We don't have the feeds in here, but when I connect the feed stream to the column, those feeds will be auto-entered. So everything should be ready. So I'm going to save it and then exit out of here. And it wants to know, change the configuration. Sure. Now I should be able to connect that feed stream. So I can left-click on the product stream from the mixer. Then I can left-click and grab the arrowhead and drag it into the icon, and you can see it did connect it. And if I opened up the graphical user interface, it would have the feed mole fractions populated in the proper dialog box. I still have to put my product streams, because you can see if I hover the mouse over the icon, it says, it even tells me that the product streams are not connected. So left click on the insert stream, and then to avoid confusion, I left click where the top product should come out, but it actually doesn't matter. You could click anywhere on that icon. It's just an outlet stream. Probably is going to ask you to identify it. So it clearly does not use the location to identify it. It wants you to identify it. So I could connect that stream really anywhere. It's just a product stream. But logically it comes out there, so it's nice to put it there. But it is the top product. I confirm that. And it's smart enough to know there's only one other product. So I'm going to put that other product in the bottom. It knows it has to be the bottom stream. And therefore, I should be able to solve this thing now. So I could, I'll do it now. I can left click on the icon and say, calculate this unit. And it's going to try to calculate it. Could give me that error message, and it did. But remember what that looks like. That's a harmless error. You can just blow through it and just keep going. It did calculate it. And we can see what the product streams look like. And you can see if I hover the mouse over the distillate product, the mole fractions, that second mole fraction is toluene, so I got the 95% toluene. But what I'm going to do is resolve the whole flow sheet so I can get green everywhere. So resolve the entire flow sheet. And again, I might see that error a couple times. So now it's resolving the first column. I do get that error. First column solved, and the mixer is kind of trivial to solve. It's actually solving the second column now. You can see by the color, solving the second column. And it should very quickly, everything's green. So green is good, and green means everything is solved. So the next thing to do would be to put in that third column, but I'm going to have you do that yourself, put in the third column. And the kind of interesting thing to do is how to create your own unit. In this problem, the idea is the paraxylene plant. You're going to create an Excel spreadsheet, or you actually could use MATLAB, or you could use Python, and create essentially an overall material balance for this paraxylene plant. And it's going to be very simple. The overall material balance is that really all the toluene and the orthoxylene that enters the plant is going to exit in a single stream, and that's going to be our recycle stream. And then the other two xylenes exit in two other exit streams. And really, that's the very simple representation of that xylene plant. And the idea in this problem is you're going to create that plant using an Excel spreadsheet. So I'm actually going to show you something a lot simpler, sort of a very simple Excel spreadsheet that simply takes a feed stream and creates an outlet stream that's equivalent to that feed stream. So I'm going to show you an Excel spreadsheet that basically is simply a pipe. It has an inlet stream, and it just creates an outlet stream identical to the inlet stream. But I think you'll get the idea of how to create your own process unit using Excel, and you can use MATLAB and Python to do the same thing. So what we're going to do is just insert an empty Excel spreadsheet into our process flow diagram. So notice under custom, so I'm going to click on the select unit operations icon, and under custom, I'm going to select the Excel unit operation. I could select Python, and I didn't install the MATLAB add-in, otherwise MATLAB would actually be an option here. The coffee flow sheet is kind of interesting because that's really a flow sheet within a flow sheet. So you can actually have a unit operation, and when you open it up, it's actually a complete flow sheet inside of a flow sheet. We're not going to use that. I'm going to left click on the Excel unit operation, then say select, and I'm going to put the Excel spreadsheet sort of down at the bottom here. And here's my Excel spreadsheet. And what I'm going to do is I'm actually going to grab, for the feed stream, I'm going to use my feed stream for the process, the BTX feed stream, but actually I'm not going to do that now. I'm going to show you, first of all, the logic of the Excel spreadsheet, sort of the flow of information. So for an Excel spreadsheet, I have kind of a top layer of control, and that's what you see if you hover the mouse over the Excel icon, or if you simply use the top layer of control. So I'll show you that in a couple minutes, where you simply edit the unit operation from the coffee flow sheet. So at that level, your Excel spreadsheet looks like any other process unit in the coffee flow sheet. But in this upper level, you have feeds, you've got parameters. So you've got feeds here, you've got parameters, and you've got products. That all communicates with the underlying software, which is going to be an Excel spreadsheet. I'll show you that in a couple minutes. So whatever is the feed in the upper level gets automatically communicated to the feed sheet in this spreadsheet. I'll show you that. Whatever's in the products sheet automatically gets communicated to the products in the upper level. And the parameters are the only thing that's a two-way communication. And I'll show you that again using some examples. I can have parameters in this upper level. It's very handy because I might want to change parameters without opening up the spreadsheet. If I change parameters, they automatically change in the parameters sheet in my Excel spreadsheet. Or if I change the parameters in the Excel spreadsheet parameter sheet, they automatically change in the upper level. The actual calculations, I have a calculation sheet, and I take information from the feeds and information from the parameters and do whatever calculation I want. In the example I'm going to show you, really there's no calculation at all. But obviously you could have a very complicated calculation, including using the solver in Excel. You calculate your products, and then you transfer that information to the product sheet. So that's the flow of information. It becomes kind of obvious when you do this kind of problem, which we're going to do now. Again, it's going to be a very simple version, but first let's open up the Excel spreadsheet and just see what it looks like. So show graphical user interface. Does want to confirm that I'm not a commercial user. So here is the Excel spreadsheet, and you can see it's got the first, it's an Excel spreadsheet. It's divided up into subsheets. The control sheet has a lot of interesting features, but maybe the most interesting one is the fact you can use various solver models. So you can actually use solver models in sequence, or obviously just one solver model. You've got to set up a solver model if you know how to do that, and you can use solver to solve a system of algebraic equations or to optimize something, a constrained optimization. It's actually quite sophisticated. You've got to save your model with a name, and then you put the name in here, and you can put the initial guess for any parameters or any variables you're solving for. we're actually not going to use it, but the ability to incorporate a solver model in Excel makes it extremely powerful. You can create models for very complicated processes. We're actually not going to do that. If we go to the next sheet, this is the feed sheet. And right now we don't have anything in here because we haven't connected it yet. We're only going to have one feed here. We could give it some other name like feed 1. If we have several feeds, we just give it another name like feed 2. So feed 2 would be a second feed. We can have as many feeds as we want, but we only have one feed. If I leave feed 2 here, it's going to want me to make 2 feed connections, so I'm not going to do that. I'm going to erase feed 2, so I only have one feed. Okay, so I've got one feed, and when I make the connection, it's going to populate all of this, and I'll show you how it does that. Products, I've got one product stream. Again, if I have several product streams, I just have to add the names here. And this product is going to have certain thermodynamic properties, a certain flow rate, and it will have mole fractions that are strung out in this region in the same order that they are in the main flow sheet. You'll see that. Input parameters, I don't really have any input parameters, but I'm going to just make up an input parameter to illustrate this. I'm going to call it UMBC is my parameter, and I'm going to give it a value of 100. I'm not even going to use this parameter, but I'll show you it could be used. And I've got input parameters and output parameters. That's only for convenience and keeping them straight. The parameters, there's really no difference between input parameters and output parameters. The calculations are the key thing, and I'm going to set that up now, but I want to go back and just check what my feeds look like here. Okay, so from B3, and when I put this in, it's going to be to J3. So actually, I'm going to temporarily close this. So I'm going to, you've got to essentially save it by saying update. If I use save as, it's going to save it as an Excel or an Excel file someplace else. I just want to update this, which is essentially saving it in the coffee environment. And then I can exit out of here. I actually exit out of here by clicking the X up here. Exit out of here. I did that because I want to show you that if I grab my feed stream, my original BTX feed stream, and connect it down here, now open up the graphical user interface again, wants to make sure I'm not a commercial user, and go to feeds, you can see it put in that feed stream. Okay? And if I had several feed streams, I just have to list them here. So that feed stream, you remember, was temperature 298, 1 atmosphere in pascals. Flow rate was 1 mole per second. That was the flow basis. And the mole fractions are shown here. That's my feed. And it goes from B3 to J3. So now go to the calculations part. And the calculations part, it's a blank sheet in Excel. You can do anything you want to. What I'm going to do is really trivial. I'm going to type in feeds here, just to keep it straight. And my feeds, I'm simply going to copy the information from that feed sheet. So I just say equals, and then I have to specify the sheet. So I have the single quote, and then the name of the sheet is feeds, and then the end quote and the exclamation mark. That means that it's that feeds sheet, and it's cell B3. Hope I remember that right. So I should get that first entry, and I do, it's the temperature. Okay, so I simply have transferred the information from cell B3 in the feed sheet And now by copy and pasting, I can get all the other information up to J3. So now paste it, and I simply now have all that information transferred to my feed sheet. Products here. Now obviously you could have a very complicated calculation that involved using parameters from the parameter sheet and information from the feeds to calculate your products, and it could even involve using the solver. You can set all that up. But here it's going to be very simple. I'm simply going to say whatever was in the feed is my product, just to make it very, very simple. So in cell B6, I'm just going to say it's equal to cell B3. So equal B3. That's the temperature. And I'm just going to copy and paste. Copy and paste. So I simply, everything that's in the feeds are in my products. Very simple example. You know, obviously I'm not really doing anything here. And a real problem, you have a complicated calculation to figure out what is in your feeds, knowing what's in, or excuse me, what's in your products, knowing what's in your feeds. And you might use parameters, and you could have to use the solver. But one way or another, you get a set of cells that has your products. And so that's in cell B6 to J6. Now you go to the product sheet, and you've got to put the results of your calculation here. So we know the results of my calculation, admittedly very simple, are simply what's in the product or in the calculation sheet, B6 to J6. So I have to say equal, single quote, calculations, single quote, exclamation mark. I don't even think you really have to have those quotation marks unless it's a multi-word name for a sheet, but to be safe, put the single quote in there. And that means from the calculation sheet, cell B6, take that information, that's going to be the temperature. So I'm taking it from the calculation sheet, the products, and now I just have to copy and paste, and I've got my product here. Obviously, an extremely simple example. You know, the whole idea is that your calculation sheet is going to be, you know, some very complicated calculation, but the idea is the same. You've got to get your feeds into the calculations subsheet, and possibly you want to read in the parameters as well, then do a bunch of calculations. The end result will be the products, and then read the products from the proper locations into the product sheet. And this information is going to appear at the upper level of your Excel spreadsheet. So I'm basically done. Again, this Excel spreadsheet did basically nothing. It's just a pipe. What goes in is going to be what goes out. But now update, which essentially is to save it within Coffee. So update, then to exit, you hit the X in the right-hand side here. Okay. And okay, everything's okay, but I do need my outlet stream. So I left-click on the Insert Stream icon, then I left-click again on the Excel sheet, and then move the mouse. I release the left button, move the mouse to a new location, and then hit the left button again. And that's my outlet stream. It hasn't been calculated yet, so it's kind of that brown-green color. It means it hasn't been calculated yet. But what I can do is I can left-click, or excuse me, let me do that again. I can right-click on the icon. I can calculate the unit. Obviously, it's going to be a trivial calculation. Didn't take much time to do it because it's not doing anything. But now I can hover the mouse over the outlet stream, and you can see it just transferred the information to the outlet stream. A couple of other things I can do here. I can edit the unit operation, and that's going to kind of show me the upper level here. And you can see this parameter that I have. I made up that parameter. It has the value of 100. It transferred that information from the spreadsheet to this upper level. But the good thing is I can transfer it the other way. So if I want that parameter to be 50, I can change it in this upper level. And now it's automatically changed in the spreadsheet. And everything else here is just kind of trivial. The ports, it's got one inlet, one outlet. Information, there's not much information there. Material balance, it does have a material balance. What's going in is what's going out. But the key one is the parameter. You can have a string of parameters here and change it. In this upper level, you never have to get down to the lower level. And that way you never have to touch the spreadsheet then if all you're doing is changing parameters. That's probably a very handy way to set things up. But remember, I changed the UMBC to the value of 50 here, and it might be interesting to see if that has been changed in the spreadsheet. So let me right-click, show graphical user interface, wants to make sure I'm not a commercial user again. Let's look at the parameters. That was a parameter UMBC, and you can see it changed it to 50. So that's pretty handy to have that upper level. You can kind of, if you're embarrassed about using an Excel spreadsheet, you can kind of fool people because they don't really have to open it. They can use the upper level, and I should note that if you right-click on the icon and you go to Edit Icon, you can change that icon to be anything you want. So, you can really fool people. You can make an icon that looks like some professional thing, and if people stay at that upper level, the edit unit operation upper level, they'll never know what's underneath. And they'll think it's some sophisticated program, but it's actually an Excel spreadsheet that you developed. So, the edit the icon, you can change the icon to look, to be anything you want it to be. I don't usually bother to do that. Sometimes I do erase the X on there, which kind of hides the fact it's an Excel spreadsheet. But that's the principle of making an Excel spreadsheet. So to finish this problem, I'm not actually going to finish it here. You would put in that third column. The third column is the Xylene Splitter. And remember, the Xylene Splitter takes the ortho-xylene off the bottom. The bottom product is the ortho-xylene. I think it was 95% purity. And the top product is what goes into the xylene plant. And the xylene plant is going to be represented by an Excel spreadsheet. A very simple Excel spreadsheet. It's a little more complicated than the one I just did, because it's essentially a splitter that directs components to the streams you want. All of the toluene and ortho-xylene will go into the recycle stream, and the other xylenes will go into the other stream. If you want a little shortcut, you might recognize that the Excel spreadsheet that you will develop for this problem actually already is available. It's something called a compound splitter. So what exactly is the compound splitter? Compound splitter is exactly what you're trying to do, but I think, if you really get stuck on the Excel spreadsheet, you can use the compound splitter. Compound splitter is like an ordinary splitter, but an ordinary splitter, the two product streams have the same composition, and therefore the same composition as the feed stream. Compound splitter is kind of a hypothetical device where you can arbitrarily direct components to one product or the other as you desire. So in fact, it does the same thing as the Excel spreadsheet, but it's a little too easy to use the compound splitter unless you really cannot get the Excel spreadsheet working. But for the compound splitter, you've got one feed. I'm not going to open it up because it's very simple. And then you have the main product and the split product. And every component, you have a parameter that goes from 0 to 1. And if it's a 1, everything, 100% of what goes in, the recovery is 100% in the split stream. If that parameter is 0, everything comes out in the main stream. And therefore, you can direct components to either of the two product streams. So it accomplishes the same thing as the Excel spreadsheet that you're supposed to make, but it's a good learning experience to make that Excel spreadsheet. You really can't get that to work. Compound splitter will do the same thing. So that is as much as I'm going to do on this problem set. I think if you get through this problem set, you really will have a good idea of how COCO and ChemSep works. Admittedly, we focused on the separations part because I'm incorporating this into a separations course. If you have a more complete process design, you'll probably have a chemical reactor, but you've got, if you go to the select unit operation, you've got various reactors to select from, a plug flow reactor, a CSTR, an equilibrium reactor, etc. So you can use reactors, you can use pumps and compressors. It's got kind of the standard things in it. And again, if you need something that's not a standard unit operation, you may have to create it yourself using either Excel, MATLAB, or Python. But it's not that hard to do. I just gave you a very simple example where we created a unit. It wasn't very impressive. It was simply essentially a pipe. So that's really all of the tutorial that I wanted to present. And so I think I'm going to end things right now. And hope you enjoy these 3 tutorials. And if you go through this exercise, I think that you'll have a good idea of how to use COCO and ChemSep. And so I'm going to stop the recording right now. Thanks a lot for listening. Hope you got something out of this. And thanks a lot.